I welcome you back to another series of our lecture. We want to talk about nephelometry, the use of an instrument called nephelometer. Nephelometry is an analytical technique that helps to measure the concentration of suspended particles in a liquid by measuring a scatter light. Now let me take it from this angle for you to understand properly. There is a difference between a solution and suspension. In solution, it is homogeneous mixture of solute and solvent. In suspension, there is presence of particles undissolved, presence of solute that is undissolved in a suspension. The presence of this solute in that very suspension can cause light to scatter. Therefore, nephelometry is the measurement of scattered light in 90 degrees. The measurement of scattered light in 90 degrees. What principles does this work with? It works with what is called Tyndall effect. Tyndall effect states that when a beam of light passes through a solution containing insoluble particles, some light are scattered. That is Tyndall effect. Please take note. You will be asked. Tyndall effect, nephelometry. What principle governs nephelometry? We know the principle that governs colorimetry, say Beer-Lambert's law. But the principle that governs nephelometry is called Tyndall effect, which means a light path passing through a solution containing insoluble particles leading to scattering of light. And this light is scattered at 90 degrees, angle 90 degrees. Now please, I want you to take note of that. Scatter light is detected at an angle 90 degrees to the incident light. More particles, more scattering, and more higher signal. Yes, more particles, more scattering, and more higher signal. What are the types of nephelometry? We have the endpoint nephelometry and kinetic nephelometry. The endpoint nephelometry measures scatter light at a fixed time after reaction completion, while the kinetic nephelometry measures continuous monitoring of the light scatter during the reaction progress. What importance does it have in clinical laboratory? Number one, it helps to measure some markers like C-reactive protein in cases of inflammation, infection. That is one of the first protein that is elevated. It also helps to measure immunoglobulin, immunoglobulin G, immunoglobulin A, immunoglobulin M in cases of immune deficiency or gammopathy. Now, not only that, it also helps to assess for rheumatoid factor, diagnosis of rheumatoid arthritis. And not only that, it also helps to study complement proteins C3 and C4 in systemic lupus erythematosus. It also helps to measure albumin, transferrin, and haptoglobin in nutritional and liver to know nutritional status of an individual. Now, I want us to understand that nephelometer have some basic advantage. It's highly sensitive and specific. Yes, it is rapid and it gives an automated result. Two, it is suitable for a topic sample. The limitations that can be encountered in nephelometry is interference from lipemic or hemolyzed sample. Required proper calibrations and control, and also it is not suitable for a highly colored solution. It's not suitable for a highly colored solution. Now, there are working steps to use a nephelometric technique. Number one is that the reagent antigen is mixed with the patient sample containing the target antigen, thereby forming an immune complex. and this complex scatter the light present on that light present in the across the light path. And in summary, we can say nephelometer is a measurement of a scatter light. Here we have another technique called turbidimetry. Turbidimetry is another analytical technique that helps to measure the concentration of suspended particle in a solution by assessing how much they scatter or absorb light. In other words, you can say it is the measurement of unscattered light. Which means it measures the reduction in the intensity of the light as it passes through the solution containing the suspended particles. The decrease in transmittance is directly related to the concentration of the particles present in the solution. Please, for short, you can say that turbidimetry is the measurement of unscattered light. What principle governs this? A beam of monochromatic light is passed through a sample. The suspended particle in that very solution scattered and absorbed some of the light, while the remaining light that passes through the solution is measured by photodetector placed in line with the light source. The more turbid the solution, the less light reaches the detector, which means turbidity is quantified as percentage transmittance or absorbance, which correlates with what? With the concentration. Please, yesterday I was talking about how absorbance is related to percentage transmittance. I gave a formula. I said A absorbance is equal to 2 minus log 10 percentage transmittance. That is the equation that is relating transmittance with what? With absorbance. Please, I want you to take notes of that. The higher the turbidity, there is higher correlation with percentage transmittance. Now, take note. Does it have application in medicine? Yes, it has. Number one, we used it to measure proteins. Number two, it is used to measure, it is of interest in pharmaceutical companies and also in food and beverage companies. Does it have the instrumentation is simply a light source. The light source, which provide a consistent monochromatic light. The cuvette, the detector. Yes, you will see it there in my note, how turbidimetry technique setup look like. The presence of a sample containing turbidity, the amount of light that now passes through is what is mentioned as the transmitted light at 180 degrees. I recap by saying, for short or simply put, turbidimetry is the measurement of unscattered light at 180 degrees. Now, let's quickly look at pH measurement. You understand that in laboratory medicine, there is a need to measure the pH of every solution. That is why the blood pH is 7.35 to 7.45. And pH is a measure of hydrogen ion concentration in a solution. It can be blood, it can be anything. There is always hydrogen ion concentration, which indicates the level of acidity or alkalinity of that very solution. It runs from 0 to 14. At 7, it is neutral. Below 7, it is acidic. Above 7, it is alkaline in nature. And there is a formula that says pH is related. pH is equal to log minus 10 minus log 10 to hydrogen ion concentration, or in other words, you can say pH is equal to a reciprocal of log of hydrogen ion concentration. What is the principle of pH measurement? Please understand the principle based on potentiometry. It's based on potentiometry, which means potential difference between the reference electrode and the working electrode, or you can say glass electrode and the reference electrode when it is immersed in a solution. This difference in potential is directly proportional to the hydrogen ion concentration present. The component of pH meter includes number one, the glass rod, the glass electrode, which helps to measure the hydrogen ion concentration. The reference electrode provides a reference voltage. The difference between these gives the hydrogen ion concentration of that very solution. What are the procedures? Perhaps you have not used pH meter before. These are basic procedures. Number one, you have to calibrate the pH using a buffer solution. Acidic buffer, neutral buffer, and alkaline buffer. pH 4, 7, 10. Having done that, you rinse the electrode with distilled water and blot it dry, and then immerse this very electrode into the sample of interest and wait for readings to be taken. And thereafter, you rinse it again the electrode immediately after use. What are the uses of pH measurement? Number one, it helps in environmental monitoring. It helps in environmental monitoring. That is to check the pH of water, pH of soil. It helps to measure the pH of food substances we take in, even the pH of drugs, and not only that, to check the pH of fertilizers and even the pH of soil. When the pH of these fertilizer and soil are not in tandem, they are not in good relationship, it can distort the soil from giving us the actual yield of crops planted. You see, it has a whole lot of application. I will be ending this very class any moment from now. Before then, I want us to quickly look at an instrument called atomic absorption spectroscopy. Atomic absorption spectroscopy is also an analytical technique used to determine the concentration of an element in a sample by measuring the absorption of the electromagnetic radiation of the specific wavelengths. Let me repeat that. Analytical techniques used to determine the concentration of an element in a sample by measuring the absorption of the electromagnetic radiation at a specific wavelength. Please, may I let you know that atomic absorption mainly it helps to measure heavy metals like lead, cadmium, arsenic, cobalt. You can make use of what? Of AAS for short. What principle governs this? The principle states that when an atom absorbs a light at a characteristic wavelength, the light absorbed when that sample is atomized. Please get that. The sample, okay, I repeat by saying that the principle states that when an atom absorbs a light, the atom has a higher energy in its atomized state corresponding to the particular light it has absorbed. The amount of light absorbed by that atom is proportional to the concentration of elements in that very sample. What I'm saying in essence is this: if I have 20 atoms in a solution and I have 10 atoms in solution B, the amount of atoms in solution A, which is 20, is going to absorb more of light energy from the incident light, meaning that amount that has been absorbed is depending on the atom present in that very sample, in that very solution, compared to solution B that have just 10 atoms absorbing an incident light. Which means the principle again states that when an atom absorbs a light at a particular wavelength, the amount of light absorbed is directly proportional to the amount of atom present in the solution. Basic instrumentation of this very AAS. Number one is light source. Typically, it uses a hollow cathode lamp. A hollow cathode lamp. You can also make use of electrodeless discharge lamp. And number two component is called atomization source, which is your flame. It helps to put the atoms, it helps to break and convert these very atoms into a free one in a gaseous state. Then monochromator will help you to select a particular light emitter, while the detector, which I said photomultiplier to, that has, or a photodiode array, will help to measure the intensity of the light, and thereafter the data will be displayed. Here in my notes I put down the working procedures on how AAS work. Number one, you have to prepare your sample. The sample will be well prepared. You digest the sample so that it can easily be analyzed. Number two, that sample that has been prepared or digested or converted will be subjected to a flame which will convert this very element into a free atom. And that atom in that element will absorb the light energy from the, yes, it will absorb the energy from the cathode lamp at a specific wavelength. And the intensity of this very emitted light now is being absorbed by the sample, which is directly proportional to the amount present in that very sample. Does it have a advantage? Yes, it has. Number one, it is highly sensitive. Number two, it is highly selective. Sensitive and highly selective. What do I mean? Which means it helps each element absorb a light at a particular wavelength, allowing for selective analysis of individual element. Which means if I put carbon into that very in that very technique, carbon as an element, it will help to absorb carbon. It will not absorb calcium. Why? Because it is highly selective for a particular word element. Number two, it has a wide applicability. It can be used to analyze a range of elements depending on the monochromator. Number four, it is reliable, which means it can give a it is a well-established technique with high reproducibility. What do I mean? I can be able to use this to reproduce a specific result, the same result repeatedly. But I tell you, there are limitations to this very equipment. Number one limitation is that matrix effect. Please take note of this. Matrix effect. Interference from other elements can affect the accuracy of the result. And not only that, it can also be, it has a limitation of single element analysis, which means, I say it is selective. It is typically used for analysis of one element at a time. That is what makes it to be limited compared to other techniques that can measure a wide range of elements at a given time, like ICP-MS. ICP-MS has a dynamic range and it can measure a lot of substances at a particular time. The application of this AAS is number one, for clinical diagnosis to measure toxic elements. I've given you examples of toxic metals: cadmium, lead, arsenic, cobalt, mercury, and so many other metals that are heavy. Number two, we use it in pharmacological industry, in food industry. We can also use it in metallurgy to analyze metal alloys in industries. Now, to round up this very class, I want us to listen to this very video. Take your time, go through it, ask me some questions where you are not clear with, and what this instrument help us to achieve in laboratory analysis. Please try to listen repeatedly. I will come up to explain further in my next class. Thank you.